Hi, I'm a student of Harmony Innovation Katy. For my P&IBL project, I chose to build a balsa wood bridge. It is meant to replicate the function of an actual bridge, utilizing a truss design to keep the strength and force resistance. Behind the principles of this truss is civil engineering and architectural engineering. However, more specifically, triangles to move and disperse the forces along the members and joints. It works by breaking down force vectors as weights or other forces are put upon it. The design of the truss allows for the dispersion of the force vector, to be dispersed into smaller vectors. These vectors have less force and are moved across more members and into joints where they are better supported. They can be calculated using trigonometric formulas. My bridges of testing is capable of holding about 35 pounds. Although at about 16.4, one of the members came loose and had to be glued back together. Testing at 30, it had some minor bending, but it was nothing too major, so it can be assumed that it could hold a bit more, probably around 35. For my ELA component, I decided to write a journal about my project design and coming up to building it. During the initial assigning of the project, I was unsure about which project to do, and it took a while to decide, but eventually I was able to decide. Upon deciding, I was able to do all the steps that didn't require for me to do the project, the actual building process. But upon coming to the process, I realized that it wasn't the project that I wanted to do. However, everything I didn't really require it. So I ended up choosing a new project. With the new project, I did everything else. I did the background research while waiting to get my materials. Upon getting my materials, I took 2 days to build it. The first day I spent cutting out all of the pieces so that I could assemble it the next day using super glue, or hot glue. The process was simple. It takes these balsa wood sticks, then they're measuring. You have to measure them into certain pieces and cut them out. Once you have assembled all the pieces, you're able to glue them together to create this structure. Now, the tools needed are really just an X-Acto knife, balsa wood stick. Even the ruler's not really needed if somebody's capable of that. Tool to mark markings along the ruler, and some hot glue, though it's possible that super glue or similar types of glue may work, but hot glue seems to be the best choice. For my specialties component, I decided to talk about where it can be found in real life. It is typically found along the design of bridges, houses, and other such long things that would need lots of support. The design of the truss allows for such support to be shown. So my favorite example of it would be the Eiffel Tower, which utilizes it for its vertical support. It allows for it to resist strong winds, lots of forces from, a vertical direction. It has been combined with other things so that it may provide for better structure, but the general design there allows for it to draw many tourists. It's been great for France. For testing, it'd be simple to start with a 5-weight, move on to 10, and the next step should be 15 based off how I've been testing it, but to work with what I have, 20, 25, 30. this is where it starts to bend. However, removing the weights and attempting to use the second 20-pound weight causes that to happen. Such cracking means that it's not very stable and has begun to bend. So it is best to stop testing after that. However, the way that it had not completely broken down allows me to assume that it could hold a bit more. Well, not more than 40, more than 30, which it was able to easily hold. Well, not too easily, but easily. 5 more pounds should be enough. Thanks for watching. I'm in a school of innovation, Katy.